All right, everybody, thank you for coming to TIC for 612 Mathematics. I'm Lynn McCartney. I'm an instructional technology consultant here at Heartland. And I have gotten to work with our first presenter for more years than I'm going to say. We actually go all the way back to the E2T2 grant. Raise your hand if you remember that. Yes. The elderly are sitting over here, so if you make your way, you'll be with Diane and I. Not Molly. Molly, you get that exemption. That's okay. Anyway, it is my great privilege to welcome you to Heartland today. I'm glad we have this today and not tomorrow because the weather looks kind of iffy. But thank you for making the drive. And I would like to introduce our first presenter, Diane Royer, and she is going to introduce herself.
I've got this mic. Oh, you got that. Thank you. Good morning, everybody. I am Diane Royer. I am a math consultant here for Heartland. I serve schools out in Region 1, which is basically out west, and a few schools down south. I do see some familiar faces out there, so I'm glad to see you. This morning, what we're going to focus on are some digital resources for you to put into action in your classes. It's not going to be a sit and get kind of a presentation. I'm going to ask you to engage and do some things with me. For those who are out on Zoom land, I've not tried to do it remotely as well, so that'll be good information for me to gather to see if the folks out in Zoom can also get that as well. So with that going on, if you haven't got your computer up and running into a browser, you're going to need it in just a minute. So get to the browser of your choice. That would be fabulous. So I'm going to focus a lot of things on rich math tasks. And we know the Iowa Core says we have to teach them. In fact, this is a quote from the Core. It says to faithfully implement Iowa Core mathematics requires teaching with rich math tasks. In other words, we don't have an option. And we know most of our textbook resources, they're pretty good at the answer getting kind of problems, a few problem solvings that are focused around the concept of the day. But as a rich math task, most of our resources, they're pretty weak. So why do we want to use them? Well, we know about focus, teach what the Core says we're supposed to teach for our grade level. We know about coherence. We know that what is taught before us should pull forward and we have a learning progression. But rigor is the part that I really want to focus on today. That's going to be the conceptual understanding. It's going to make sure we've got procedural skill as well as fluency. And we have to have knowledge that I can apply to new math situations. Problems that really haven't come up before. And I always use this illustration to kind of drive that point home. Think about your car insurance. There is a plug-in from a company that you can plug into your car and it records your driving habits. That particular device can be hacked and hackers can control my car. That's not cool. That's not a problem that existed just a year ago. We want our students to be able to apply math in situations that are new that haven't existed before. And that's one of those kind of issues that I can always bring up that we can relate to, those kind of problems. So what's involved in a rich math task? Well, this is direction that comes from our Iowa Core. We have to teach through problem solving and get problems that can be understood. We have to use distributed, meaningful practice. Okay, what that means is I have to build on a concept and bring it back frequently over and over and just bump up the level of rigor and understanding. If I use it once and I don't get back to it, that old phrase, if you don't use it, you lose it, that's what's happening with that. So we want to make sure that our math tasks are including that distributed practice. So here we go. I want you to open up the browser of your choice, and the first one I'm going to talk about is Desmos. So if you want to go to student.desmos.com, if you want to head to that site, please. I'm going to use two separate activities here. Desmos, most of you might think of it as having that really great free graphing calculator. But they have a rich library of classroom activities that are consistently being added to. We're going to be working on one this morning called Function Carnival. Function work starts loosely in 8th grade and builds on up through high school. And in this particular one, I chose to focus on this because in all of my teaching experience, and I've taught 4th grade through algebra, I know students are really having a hard time with graphing. Okay, so this particular first item we're going to talk about is on graphing. Did you get to this URL? Okay, you're waiting for a code? Here's your code. H23W. Once you put it in, it's also going to prompt you for a name. Any name you want is fine with me. If you want to be some movie star today, I am okay with that. Okay, now, H23W, okay, for that code. Now, I want you to go ahead and work through this. What's going to happen in this particular one is they're going to show you a scenario, and you have to figure out how to graph it. So I want you to go ahead and work through it. As you're working through that kind of an item, these are the goals that I'm going to say we are going to try to establish. Are we having luck getting in? You're seeing a little video? A 10-second video? Yes? Watch it twice, maybe 3 times if you want. Hit the arrow on the right side of your screen and progress. Okay, now do you see you have a piece to graph? Try to graph. And I'm watching a few screens that I can see. As you're thinking about the graph and what to do, I want to point out that this particular activity would be wonderful practice as we move possibly towards that smarter balanced. We're in the middle of that right now, where students will have to use dynamic geometry tools to graph. This would be a wonderful practice for that. And I will let you try it out. And when you think you have your little parachuter graphed fairly well, you can try and match it up. And then you can move to the next one. There are 3 scenarios here. If you haven't got past the parachute, I do want you to experience a few others. The 3rd screen is the most challenging in my opinion, the bumper cars. And so I do want you to get to that. The question came up when you're looking at the responses, you type something in and you can see other people's responses as well. The question was, does the computer go back and tell you if your question was satisfactory? And the answer is no. That's where you apply your teacher craft and you get those responses on the teacher side and you can respond. I also want you to consider when it's asking you to give a question or respond to another person, how that's going to deepen your own understanding of the problem. If you're asked to analyze someone else's misconceptions, I think that deepens your understanding. All right, if I can talk to you now about what do you think some student misconceptions would be? What do you think some students' misconceptions might be as they engage in this task?
I think one thing is when you watch the person go up and down, the students don't see it being a time versus distance graph. They're just going to assume the person's supposed to go up and down on the graph and not realize that they're supposed to look at how fast they're going up and how fast they're going to come down.
For those on Zoom, she said a misconception would be students would think it would go up and down, not realize there was a relationship between time and distance. Yes, others?
I think a lot of students would want to draw a graph like the middle student did of the actual path as opposed to, so the Ferris wheel would actually, in their behind, look like a circle.
So out in Zoom, that comment was students might think it's going to be drawn as an actual path. And looking at that Ferris wheel, they might think they need to draw a circle. Any others? We covered this quite a bit here. Misconceptions, I think what I most often see, especially when it comes to drawing that bumper car graph, that they've really got a misconception of the distance and time. If I go backwards, time travel doesn't work as far as I know. And yet those students want to draw that graph as going backwards with the path of those bumper cars. So I think the progression of this is pretty good. Now I want you to focus your thinking on our standards of mathematical practice. And there's a quick Cliff Notes version of our SMPs, our standards of mathematical practice. As a student, or as you as a participant this morning, take a look at those mathematical practices. What might apply to this activity? Problem solving, hello. More. Modeling.
Viable arguments and critique others.
Viable arguments and critiquing others, especially when you had to write what someone was thinking that was, you had to craft their thinking differently.
I have a question.
Yes.
How do you move the students from just trial and error? Like I got really frustrated with that, and I wasn't really looking at the axis. I was just trying to get it right, and I guess kept playing and playing. So how do you move past, how do you build that motivation to want to do it, but then also move past trial and error and actually have them think mathematically about it, not just...
Good questions. How do I make students actually engage and not do trial and error? When I have tried this with older high school students, they want to try to break the graph. It takes a while to get in there. On the teacher side of this, if I would go into my account at teacher.desmos.com, on the top of it, there's going to be places that show me very precise graph and the names there. And that's going to say those who need help. Well, I can go around to those students who need help, and I can say, try something, make a mark on the graph somewhere and see what happens. So I like to think of this as a low floor, high ceiling task where everyone can engage. Those who are, frankly, clueless can at least try it and try something, even if they're making a lovely X in the middle of the screen, and then they run it, they can see what happened. For those who need to engage and say, well, you're not as precise, you're not up on my list. And that usually works pretty well to get them engaged in that. Now, and the teacher side of this, and I won't publicly display to have this filmed forever with your names up there, but on my teacher side, I will have the names listed along the left-hand side of my screen. If there is an issue that students have not progressed along, I will get an orange triangle, I believe, and that will show me what screen they're on and if they haven't progressed. Then that means I can look at that and I can walk over and I can ask questions of them. Well, what are you thinking? What are you wondering about? What have you tried? All right? Can we try another one that's completely different in the same site? All right, so this one was a individual look, explore, not really any words. You started out watching this guy parachute going, okay, now what, right? No real direction. All right, so if you want to continue on that student.desmos.com site, here is a brand new one for you to go into, and the code may not let you go until I start it yet, so you may get held up. I may have to go back and refresh another screen back on my other browser. This one is going to be Central Park. We know in mathematics we need to move from the concrete to the representational to the abstract. This one, you are a parking garage. And it's going to move you from the visuals to the mathematical equations. Is it opening it up for you yet, or is it on hold? You're opening. As soon as you're in, go play. I'm going to give you roughly 10 minutes to work through this. This is much more involved than your last activity. And as you're playing as a participant, put your teacher hat on as well to notice how it is moving from the concrete to the representational to the abstract. Again, if you were out in Zoom land and needed those directions repeated, you're back on student.desmos.com, and your new code coming in is N78A. As I'm walking around, I'm seeing various strategies in dividing your space. Some of you are moving your divider to the middle and then taking each half and dividing those up. Some of you are just eyeballing it and deciding to try it and guess and check. Whatever works for you is fine. Remember, as you're progressing, I want you to think not only as a participant in the activity, but also with your teacher hat as we've moved from concrete to representational to abstract. If you have finished ahead of others, here's where I want you to go. If you are a gifted Parker and you just whiz through the activity, this is when you're done. If you're not done, ignore this. It'll come up later. I'll bring it back. You don't have to write it down now. But if you're done, I want you to be involved in this one. If you're not done, keep progressing through your parking situations. All right, I'm going to call your attention back to the front, please. If you're not done with the Central Park, it is okay. As I went through this activity, this is what I tried to link it to for my Iowa Core standards. I thought I could start looking at as far back as grade 6 with my expression work, continuing into grade 7, and obviously high school. Now, I ask you to think about how this moved from concrete to representational to abstract. Anyone want to share some of their thinking on that? Yes.
It started off having you just physically park cars and just drag the dividers. And then it took you a little bit away from that with actual numbers where you had to do some arithmetic. And then it led you into the algebra, which is where you're heading into your abstract.
Excellent. Out on Zoomland, she had talked about that it was first on just dragging it visually. Then it worked with numbers and advanced toward the variables and putting it in an equation form. I also like that it made you put it into words. You justified your thinking. You also had one where you had to agree or disagree. You had to take a position. So again, if you're thinking about those standards of mathematical practice, I believe this activity is rich in the standards of mathematical practice. The last question I have on here is a DOK. Now that's short acronym means depth of knowledge. And we know that every standard in our Iowa Core has a depth of knowledge attached to it. There are 4 depths of knowledge, 1, 2, 3, 4. And again, those are not taxonomies. It's not like a lot of people try to relate it to Bloom's where I want to get higher level thinking. DOK's depth of knowledge are not like taxonomy. Instead, they're the levels of cognitive thinking that we need to do. Now, there's only one DOK 4 in our entire Iowa Core, and that's in my high school geometry. I would like to have a lot of my rich mathematical tasks stand at a DOK level 3, which means I have to have some knowledge recall things going in, DOK 1. I have to do some more than one-step problems, DOK 2, but I'm also going to have to strategically think and apply. Did you have to strategically think and apply in this activity? All right. Now, Desmos is free. If you go to Desmos yourself, just desmos.com, forget the student in front of it, desmos.com, it's going to show up to begin with as Wonderful Graphing Calculator. But up at the top of your screen, toward the right-hand side, you will find a block called Classroom Activities. There are dozens. They are added consistently. I was at a training that I was providing at another school in late August. And the night before, I had made sure all of my links were good. Get there the next morning, a new activity had shown up, and where I told them to go, it wasn't there anymore. It's consistently being added to, not only by the creators of Desmos, but also by other math teachers across our globe. In fact, you can make activities on Desmos and post them here for other users to put in. A couple others that I have tried. There's one called Penny Circle. Now, I'm thinking back to my days when I was gathering data from experiments in my classroom. And we were gathering the data, and we had the Texas Instruments where we had to go back and make our lists. And that took so much time to set them up, where the math learning just kind of stopped while we did the data collection piece. You had to set up list 1, list 2, you had to get it in, and invariably somebody hit the wrong key on their calculator and it wiped it out, or they didn't know how to do it. That penny circle particular one, everyone who's in the activity gets a different size circle where you're trying to see how many pennies fit inside the circle to work with some particular math. But Desmos graphs everybody's data for you. And as you're progressing, you see your classmates' data in there, so you don't have to halt the math. The data is collected for you, and you can progress through your function learning. Another one of them, and a piece of having a rich math task, I should have some collaboration going on, more than just me to a computer. So there's another one that's called polygraph lines, I believe. There's several polygraph activities. This particular activity lets the computer teach you what to do for the game, to ask yes and no questions to identify a goal, and then based on the speed of participants responding, we'll partner you up with another participant in that activity where you're trying to look at 2 lines, or even just a single line, depending on your activity, to define which line it is out of a variety of maybe 20. So you're having to ask about intercepts, positive, negative slopes. Does it pass through such and such a line? It does it with parabolas as well. And the students are interacting back and forth, asking questions on the computer. Before you leave this particular activity, I want you to know that it is growing by leaps and bounds. You may know the name Dan Meyer. Dan Meyer is most popular for his 3-act math tasks. Dan Meyer is now employed by Desmos, and he is consistently writing activities. The Central Park activity was crafted by Dan Meyer, and so a lot of you might have that connection, and I think it's very valid. Now, not all of you got to go here, so I do want you to go to this link. This link is gameaboutsquares.com. This is a good thinking logic game. Whenever I'm asking students to do something digitally, they're going to finish at different times. I don't want them to shut down. I don't want them to get into mischief. I want them to continue thinking. This particular game, there's nearly no directions. You see circles and squares and directional arrows. Try to figure it out. I'm not going to give you any clues. This is called the standard of mathematical practice. Persevere in problem solving. You can do this as a guest, or you can log in. I did log in with my Google credentials. Push it over to where? I like that. Thinking, problem solving. Try it. See what happens. Now, the initial directions that came from the creator of this game ask you to progress through levels 1 through 8 before you go looking for any hints. Are we making sense of it? Got level 1 accomplished? I'm seeing some fist bumps over there. I like that. All right, talk to me about this game. What's the math in this game? Why would I bring this game to you? What math might be embedded in this?
Problem solving.
I'm hearing problem solving.
Logic.
I'm sorry?
Spatial reasoning.
Spatial reasoning. Something over here?
Logic.
Logical thinking. The puzzles progress. They get pretty deep fast. I'm currently trying to solve level 11. I didn't get real far. 1 through 8 went like a breeze. 9 and 10 made me really kind of, okay, I got to think about this. And level 11, if I hadn't got it in the first 3 or 4 minutes, my time was up. But level 11 is really kind of, I really have to think at this point. All right, I'm moving on. I got more to bring to you. You can let that screen save later. You can come back to it. Let's go to the next one. If I could have your attention back to the front of the screen, I want another tab up. This one is called solveme.edc.org. When you get to this particular screen on solveme.edc.org, you'll have 3 choices. I want you to click on the mobiles. I believe it's at the far left-hand side. And once again, you can do this as a guest. It just won't save your progress. Or you can log in. It is completely free. Now, this doesn't have to be just limited to grades 6 through 12. I could take this down and probably dial it down to my upper elementary. This is balancing mobiles. And I like this one because it lets me differentiate. If I guess incorrectly, oh, I'm seeing stars, I'm hearing stars going by. If I guess incorrectly, the visual orientation of my mobile will tilt. Again, it's one of my low floor, high ceiling activities. I'm having to figure out values for colors and shapes. I'm having to do simple, to begin with, one-step calculation, solving for one unknown variable. These get dramatically more difficult. So if I have my very advanced high school mathematics student and he's level 1, he's going to roll his eyes at me. She's going to roll her eyes at me. But I can go into the higher level ones, and there are some that will make them cry. So we can challenge everybody. Now, I've seen this one used further. I've seen a teacher use this particular activity. Students are working it through, and the teacher has chosen a mobile 4 or 5 ahead of what they think they're going to get to, and pulls it up and wants the students collaboratively to solve that one and to write down the equations that would match their thinking as they solved it, so that they're trying to rationalize every step of the way how they balanced it and how the equation would work. So don't think it has to be a solo activity. It could be class collaborative. That is the Solve Me puzzles. Okay, conversations on the very beginning one were, how can a, I don't know if it's a heart and a triangle, be the same value? They could. Just because they are 2 different shapes doesn't mean they couldn't be the same value. Don't think of it as variables. You're looking at balancing. Okay, I'm going to draw your attention back up here again. And I have a screenshot of a website called wouldyourrather.com. Maybe you remember this as WYR.garbage. They've recently moved their website, like within the past 4 or 5 days, and it's migrated to this particular site, wouldyourrather.com. I know my students need a lot of practice in justifying their reasoning. Pick a position and tell me why. This particular website is filled with scenarios that let students decide. And I happen to choose this one. This one is asking me, would I rather wait in line A or line B to fill my vehicle with gasoline? And let's see, the gas station costs more gas. Okay, number one, I probably wouldn't want to go there. Thought that was a real interesting name, costs more gas. But now I can see the type of vehicles and the quantities of their gasoline tanks. The caveat is the pump for the gas can go on either side of the vehicle, so you don't have to say, well, I've got to go on this line because the gas tank's on the left side of my car. You take that out of the equation. Now, the students simply have to pick a position and justify it. So I've had people add them all up and decide who's going to go faster. I've had people say, I want B. This is one transaction with the credit card. It's a SUV with the boat. You won't get this particular screenshot. I scrolled and scrolled and scrolled to find one I thought I could make a visible piece here. What's up now? Is it the water or what's up first? Feast, maybe the Thanksgiving feast? Yeah. They come up with new ones all the time. If I'm asking my students to write, I better give them something to write about. There are scenarios after scenarios. Some are silly, some are real world, some are just like, who would have thought of that? Okay. All right, I have one more now that we've got that one straightened out. So is it wouldyourathermath.com? Is that we finally worked? Yep. Okay, I will change that on my notes as well.
I changed it on the agenda.
Thank you. All right, so now I want to move to one more. And before you go to U cubed, I'm going to set this one up, and it's going to be visual things on my screen. So it's going to be things I'm going to need your eyeballs on my screen to do. Then I'll tell you where to find it at. Joe Bowler has a website called ucubed.org. And this website has dozens of math tasks, ranging from preschool through my advanced mathematics. All right? She is one that is currently quite popular, talking about a lot of growth mindset, praising effort instead of grades, having all students enter a problem where they're at and progressing. She is the one that I borrowed the phrase low floor, high ceiling task from. That makes a lot of sense to me when I look out at my classroom of learners, and they are so diverse, and I want to make sure I can engage everybody. So I'm going to show you an image now, and my directions are up here on the screen. I'm going to show you an image, and this is what I want you to think about. I want you to think about how you see the image growing. And then think about that. Then I'm going to have you share that with someone you're sitting close to. Not to me necessarily, but someone you're sitting close to. You understand your task? Yep. Okay. Think by yourself for 20 seconds or so. Did everybody get a chance to share how they saw it? Okay. I tried to use some movement in PowerPoint to try to describe it. See if I've captured the ways you've seen it. I think some people see it by the bottom layers growing, like this animation. Anybody see it like that? Show of hands. Okay, I see. Okay, bottom layer coming up growing. Yes? That's not you, it's okay. How about this one? Some people see it like, and I consider like raindrops coming down. Another layer coming down, almost like raindrops or maybe lava coming down. Yeah, anybody see it like that? I see lots more people seeing it like raindrops. Okay, I'm going to make your brain twist a little bit. Unfortunately, this is the way my brain saw it, was this way. Do you see it forming a square? So on the left side of my screen, I see case 1. And I took that piece off the left, and I plopped it over there and made a square. That's how my brain sees it. I know, I'm a little twisted. Did anybody see it as a square as I did? Please? Thank you! I have a fellow thinker. Sympathy wave, I'll take it. All right, now, I'm going to go back to that image. There. Okay, now, think of those 3 ways I showed you. And the way you saw it, now to think of those other 2 ways. Can you visualize those other 2 ways? And that wasn't the only ways to see it. Maybe you had something more creative than I could produce on PowerPoint. Can you see the bottom up coming? Can you see the raindrops coming down? Okay, now work with me. Can you see how I can get squares? How I can take part of them and turn them over and lay them in? Excellent. Now, the reason I wanted to bring that part about the squares up, and let me get back to where I was. Yeah. If I would ask the students, instead of just visualizing it, how many cubes would be in the nth case and how many squares would be in the 100th case. Okay? They might be able to do that because I'm going to guess they're going to go procedurally and they're going to set up their T-chart. And I'm going to say, they're going to say in case 1, I had 4 squares. So case 1 plus 1 more squared. In case 2, I had 9 squares. Case 2 plus 1 more is 3. Squared is 9. In case 3, I had 16 squares. Case 3 plus 1 more is 4. 4 squared is 16. So it'd be really easy to get that 100th case. 100 plus 1 more is 101. 101 squared would be my answer, whatever that is. I could care less right now. But my question comes back to the children. So what if I had n number of squares? What does n represent? And they have a lot of difficulty with that if I've just gone straight to the procedures, if I've just gotten straight to the algorithms. This particular activity is called Squares Upon Squares. You find it in U Cubed. U Cubed is a site that's voluminous. When you get to U Cubed, up at the top of the screen, you have words going across. There's a word called Math Tasks. And when you get into Math Tasks, you have a bazillion choices. Okay, maybe only a dozen. But then you can choose Math Tasks. You can sort by concept, by grade level, by domain, by mathematical practice. And your activities are there. This is all free. If you haven't played on U Cubed, it's time to explore. Now, I have not done the typical presentation this morning of, here's a cool app to use. Here's a tool to use. Instead, I've chosen to give you digital resources that will let you teach your concepts, have students richly apply the mathematics that you've taught to your students, give them opportunities to think differently, to explore, to collaborate, to justify. And I've housed all my resources. This is a brand new under construction website, royermath.weebly.com. That's what it looks like when you go there. The second task tab over is called Math Tasks. I have a slideshow of a document as well as a downloadable PDF where I've collected over 30 different places that house this. So I'm going to take you out and take you a look at that right now. So if you want to see what that looks like. My computer comes back up. So in this Math Task, when I click over there, the very first one, when it loads, here it comes, is a slideshow. And if your mouse is in here, you can slide through. I've tried to give you an idea of grade levels that goes on there. I had so many, I had to pick some of my top favorites. These are not easy to copy or paste or click. So if you like to do that, which is me, directly below the document, here's that PDF you can download, save to your own resources. I'm consistently working on this website, adding things as I find them. There's more than math tasks in here. I have apps and links. So if you've got students preparing for the SAT, here is a wonderful resource. If you want to look for particular math sites for algebra, what if your colleagues are down in the early elementary? I've got lists for K2 iPads. I have 3-6 iPads. What if you don't have iPads and you're all web-based? I got you covered. I've got things there as well. There's also a new website I've just found called Bovine Math out of Canada. That's pretty interesting stuff. This website, I have articles that I think are good pedagogical reads, things you can look at. Early learning can have supertizing and place value, resources, Iowa Core, and more. So I offer this resource to you just as a place where I will keep it free, keep it available to you. You can go and download anything you want. As we end this morning's presentation, do you have any questions for me?
I had one, Diane.
Janet.
Way back at the beginning when you were talking about Desmos,
Mm-hmm.
you were
No, I do not. They just lose their placement. So here I am on the Desmos site, and here was all of our work going in, and here's the things that people are doing, so I get to see all the interesting things that my students have done. And I could pick on someone. Now, I happen to know Sophie is not in this room, okay? So you can pick on a person, and you can say what they're talking about. And so this is just Sophie's work and what Sophie put in there. So I can see that kind of information. All right, so if I go back and if I just go to the desmos.com and I go back to classroom activities, the lineup of them is different. So that's what changes. I do not lose any information. It's forever in that code. This was the function carnival we did. I love tile pile. If you would like to have something that's available for your 6th grade students as well as up, this one's dialed clear down to 6th grade. Tile pile is wonderful. This is that penny circle I was talking about. Different data collected for you, so you don't have to enter it individually into your calculators. This polygraph, this one's on parabolas, although they do have it straight for lines. We did Central Park, but if you want, you can make your own activity. And there are tons there. If you want to explore all these other activities by Desmos, there are all of those. If you want to do custom activities and browse all of them, now this is going to make you dizzy, but this is going to show you the top 16 by Desmos. And then I have all of these by other educators across the globe that are fabulous. So you could, I mean, I'm only down this far on my scrolling. There are literally dozens of activities. Did that help answer your question? More?
So when you sign in as a teacher, is that when you get your codes?
Yes. So for example, if I wanted to launch, the question was, so when I log in as a teacher, is that where I get the codes? Yes. Let's say I want you to do a polygraph line. So I'm going to click on, I'm logged in as me as a teacher. My name's up here. I'm logged in as a teacher. I'm clicking on the Desmos, and I'm saying new session. When I say new session, poof, there's my code. Easy as that. And it logs it all for me.
Can I ask you a question?
Yes.
You have a whole lot more activities showing up than I do. Is it because you're logged in?
Yes. The question was, I have many more activities showing up than she does. Was it because I was logged in? The answer is yes. You're probably going to see the top dozen created by Desmos. If you log in and you go there to the very bottom, you can see all activities. That's where these dozen show up. Next question.
In the Desmos, when you set up, you don't have to enter like a student roster or anything. It'll take care of that when the students enter in.
Right. And I do have the list that I see, and I make plain in my classroom. It's for if it's a participation grade, a learning grade, whatever it is, if you put in as Mickey Mouse, there's no Mickey Mouse on my roster, you don't have a grade. Okay, or whatever creative name they choose. All right? More questions? We talked about the would you rather. We talked about U cubed. We talked about the solve me. Here's level 11 on the squares. It's currently got me twisted. If I could solve it for you, I would, obviously. This is where I'm stumped. Yeah, so I mean, I can do all sorts of things and I can get them up, but it's not going to work as soon as I go there. Yeah, okay, so now I'm not there. So this is not working well for me. So I have to reset.
David's on level 13.
David, you and I need to talk. Excellent, excellent. I thank you very much for your kind attention. You can reach me through Heartland. My email is droyer@heartlandaea.com. I'm excited for all of you to take some of these activities back to your classroom. .org. My apologies. droyer@heartlandaea.org. Thank you.
Thank you, Diane.